Hi everyone, welcome to the training. I hope you all are doing well and let's begin the class. So, yesterday we discussed about DHCP and we learned about how DHCP works. We tried to do some practicals with this where there was one router. With that there was a switch and few PCs were connected with this switch. So So instead of configuring the IP address on PCs one by one, we configured DHCP on this router, and this router worked as DHCP server for these PCs and assigned them IP address from the network 192.168.10.0. And after that, there was another switch with whom there were few PCs connected, and these PC got IP from the network 192.168.20.0. So when you try to ping these PCs from these routers, the communication will work, and these PCs will be able to communicate with each other. But whenever you try to ping this PC from any device from this network, that won't work, because for that you need something known as routing. So you have to configure routing to make the communication between different networks possible. So in the very initial classes, in the very first few classes, we discussed about uh, PCs which were connected together, and I asked you if this PC have a IP from this IP range, and PCB is assigned with the IP of 192.168.2.1. So I asked you whether these PC will be able to communicate, and as an answer, there was always a no. Why? Since they were in different networks. So today we will learn how to make A communicate with B when A is in some different network and B is in some different network. We will be using packet tracer to learn about this. But before that, I want you guys to understand what are the different types of routing which we will be looking into in the coming days. And so to make communication between different networks possible. So when we talk about routing protocols, there are majorly two categories. The first one we have is static. Then when we talk about the other category, it is known as dynamic. Static is something related to manual. So here you have to configure all the routes on the routing table of the router to make communication possible. And in the case of dynamic, you just have to advertise your route. So we will understand this. So as of now, you can consider this as a manual thing, and this works something automatically. So again, now this dynamic category is divided into two types. The first one we have is interior gateway protocols. Then we have exterior gateway protocols. So in order to configure network, let's say within an organization or between two branches, you can use something known as interior gateway protocols. There are three different types. The first one we have is distance vector. So these are just the name of the protocols and we will discuss the further details about these protocols in the coming days. So this is just an introduction. Then we have distance vector. Okay, can someone tell him to try joining with the link which I have shared in the chat? Please, someone type the thing that try joining with the link I have shared above. Now, the first protocol we have is distance vector. Then we have advanced distance vector. And the last one is link state. And when it comes to exterior gateway protocols, we have only one, which is path vector. So the popular name of distance vector is RIP, which is not rest in peace. And then we have advanced distance vector, that is known as EIGRP. Then at last, link state is known as OSPF. And for path vector, it is BGP. So RIP stands for, okay, we will look into these now. And after that, once we are done discussing the introduction, once we are done with the introduction of these protocols, we will learn how static routing works. And today we will do a practical related to static routing. We will make devices from different networks. Okay, so yeah, we will try making them making the communication between devices from different network possible. So yes, so RIP stands for Routing Information Protocol. Then we have EIGRP. EIGRP stands for Enhanced Interior Gateway Routing Protocol. Then at last we have OSPF, and okay, so we have OSPF. OSPF stands for Open Shortest Path First. So we are just discussing the full forms of these routing protocols as of now, and then we will look into these later on. Then we have Border Gateway Protocol. So let's move to now static one, and let's understand how this works. So before moving further, I would request you to focus here while I am performing the lab. And once we are done, I will create a file which I shared today, something similar to that for you guys for your reference. Then after that, you can practice. I will give you the time. So let's get started with the packet tracer. And here we have the packet tracer with us. Okay. So we will create a topology, something similar to what we did yesterday, and we will learn, first of all, with the same case, then we will look into some other topologies as well. So we need one router for that. I have just dragged the 2811. Then we need two switches, and we will place two switches in the topology. Then some PCs. Let's take three PC. 1, 2, 3. 1, 2, 3. And just bring this a little up. Is EIGRP hybrid? Yes, it is. And we, as of now, Shubham, let's talk about static routing only. so that others might not get confused. We will talk about EIGRP when we will discuss. Okay, so as of now, the answer is yes, but we will discuss about its explanation later. So it's not working, sir. Okay, what is not working? Are you guys not able to join the class using the link, or is there something else? Is there someone in meeting who has joined the class using the link which I had shared in the chat? So the link is working fine, right? Are you guys able to see the screen, or is there anything which needs to be corrected? Let me know. So all good, right? Shall we move further? Great. So we will just go to connections. We will choose the great. Let's focus now. So we will automatically choose connection type, and we will click on this while pressing Control on the keyboard so that we can make multiple connections at the same time. Now connect the router with these switches and then these switches with the PCs. Again with this switch, then connect these PCs with the switch. So we will create a note here that this network is going to be 192.168.1.0, and similarly this network is going to be 2.0. So for that we need to configure a IP address on FA00 as 168.1.1. Then for FA01 we need to configure 2.1. Right? Clear till now? Now, in order to make these PCs working, we need to first configure the IP address on them, and we'll be using DHCP only, so it will help you to revise also, and it will help us further in the static routing practical as well. So we will quickly go to the router. We will go to CLI. So yes, first of all, you have to type no, then press enter. Now we will type enable to get into the enable mode. And once we are here, we need to configure commands. We will go to the global configuration mode. And to go to that mode, you need to type configure terminal. Once you press enter, you get into the configuration mode. Now we will go to the interface, which we need to assign IP address to, and the interface is FA00. So we will type interface FA0/0 and we'll press enter. So once we are here, we are ready to assign it IP address 1.1. Sure. Okay. Yeah. So now we were assigning IP address to the interface. We wrote IP address, then after that we entered the IP address. Then after this, you have to type the default subnet mask with it, which is 255.255.255.0. And once you press enter, you have to make the port up by entering no shutdown and enter. So once you click enter, you will see the red triangle getting changed to green, and at the same time the switch is also loading we will discuss about these different states of this loading, and once the loading is done, it will turn to green. So you can also click on this fast forward button to like make this to make this or to make this fast, or skip the just to skip the holding time. So once you click on this, you can make things faster, like make the process faster. Now, once we are done with this interface, we will move to the FA01, and now we will go exit and get back to the configuration mode. We'll go to interface FA0/1 and we'll assign IP address, which is going to be 192.168.2.1. Then we have to enter the subnet mask. Once we are done with this, we have to type no shutdown and press enter. Now I want you guys to see this red triangle getting changed into green. Once I click enter, and the port will become up and the triangle will change to green. And when you look at the switch end, it is still loading. And if you click on this fast forward button, you see the triangle got changed to green now. So the link is up and the devices are successfully connected. Now we will quickly configure the DHCP pool for both of the interfaces, and for that we have the command IP DHCP pool A. Then we have to type the network which we are going to configure, which is 192.168.1.0. With that, you need to enter the subnet mask. Now you have to tell about the default gateway. So it's going to be 192.168.1.1. So once you are done with this, you can enter exit and go create another DHCP pool. Network 192.168.2.0. Then we have to type the default router, which will be 192.168.2.1. And once we are done with this, we can press exit. We are back to the enable mode. So green signal means interface is up now. Yes, green signal means that interface is up. So we are back to the enable mode. So we have successfully configured DHCP. Let's quickly go to PC and check whether our DHCP configuration is working or not. Go to desktop, then click on IP configuration. Once you click on DHCP, it should get the IP address automatically. So yes, it's working. As we can see, the IP is assigned. Then we will go to the PC2 and we'll follow the same process. Okay, every PC is getting IP address successfully. So this PC also got the IP address from 2.0, which is 2.2. Okay, so this was something which we did yesterday also. This might have worked as a revision for you guys. So now we will check whether these PCs are able to communicate with each other or not. In that case, we will go to this message and we will click on this. And after that, you can click on the PC, then the PC you want to make the communication with. So let's try with this PC and we can see successful. So yes, the packet went through and it received the reply also from PC number 1. Now let's try the same with the third PC. We clicked on the PC number 1, then we clicked on PC number 3, and yes, it's successful. Okay, so devices are able to communicate with each other. But when you try to make this PC communicate with a PC of different network, which is 2.0, you will see that it gets failed because routing is not yet configured on this router. So we still have to configure routing to make this communication possible. Now we will look into this, how we can make the communication between these different networks possible. So yeah, yes, okay. So we have something in chat. Okay, yeah. So can you please ping again from PC0 to PC3? Sure. So we have PC0 here and PC3 here. So these two devices are again in different networks. And when you look at the, okay. Okay, so since these we mistakenly chose the same router for both of the networks, the devices are directly connected with each other, and when the devices are directly connected, the communication will work since they are still in the local area network, right? So you don't have to just worry about this, and we can like place a different router for this. So what we are doing here is, since these two networks are under the same router, the router can make these communication possible. But if there was no such routers and these were connected through switch only, this communication would have been failed. So in order to work with static routing, we are adding another router with this, and we will configure another network for these devices. So let's do this quickly, and let's configure a different network here, which is 192.168.3.1. So I want you guys to focus here right now, and we have to just connect this router with this router. So to make that possible, you need to add some ports to this router. We will go to the physical tab, we will switch it off, and we will add some ports. To make that possible, you have to just like install some modules on the router. So we are just taking 4 Ethernet ports, this one, and we will turn it on again. And once you do this, once you just switch it off and put some module and turn it on back, all your configuration will be gone. So I would request you all to avoid doing this, and which I just did, because of which all our configuration would have been gone. And if we see, so there is no DHCP pool, and we have to repeat the process again. So this will work as another revision for you all. We are connecting these two routers, and we will quickly add up all the configuration. I'm doing this a bit fast since we all have discussed this already. I'm just repeating the same process which we just did before this. Then we go to interface fa0/1 and assign it a IP address. Now we are creating IP DHCP pool for network 192.168.1.0. Then we will add default router, the IP of our gateway. Then press exit, create another pool. So since we wrote something wrong, we can just simply either create another pool, or you can just type no IP DHCP pool V. So once you click this, your pool V will get deleted from the router. So now we will type IP DHCP pool V. Network we will choose is 192.168.2.0. With that, you have to type the default subnet mask. Enter. Exit. So now we are done with the thing which we lost because of making switching the router off, and IPs are working fine. Let me quickly check them all. Okay, great. Now we have another router here, and we have another network for that router. We will add no, enable. We go to configuration mode. I hope you guys are able to see the commands, right? Great. So now we will go to interface FA00. Now we are working on this router. This is router number 2. We will go to interface FA00. We will assign IP address to it, which is 192.168.3.1. Okay. With that, we will add the default route. So we have to type no shutdown, and the port is up. Let's exit from the interface and configure the IP DHCP pool for this network. We have another network here, 192.168.3.0. And for this network, we have a gateway IP 3.1. Now we have a network here which is 1.0. We have a network here which is 2.0. Since they are connected together over the same router, they can communicate with each other. The first packet was failed because of something known as ARP, which we are yet to be learn about. So that's something usually happens. There was nothing wrong in that also. So if you try to make these PCs communicate, they will work since they are connected through a router. But when you try to make communication between devices from this network to another network, which is this 3.0, yes, we will share the commands, don't worry. But before that, please focus here. That communication will fail. If we try assigning the IP address to this. Okay. So the first packet which we tried to which we used to make the communication possible got failed. But after that, once the PCs learn about each other, once the IP is shared with the switch and routers, you can start start communicating with each other when you are connected under a same router. So these all devices are locally connected because they are in the same network. But if you try to make communication between a device from this network, let's say the PC0, with a device from this network, which is PC6, that won't be possible. Why? Because now this this PC is in a different network, which is 3.0, and with that, it is again now connected with a different router. So you have to create some connection between these two routers to make this communication possible. So for that, you have to assign some IP addresses on these ports as well, which are connecting these two routers together. And you have to make sure that both of the IP address has to be from the same IP, from the same network of IP. So if we are configuring like 192.168.4.1 on this Ethernet 1.0 of router 1, then we have to make sure that we assign an IP of the same network to the port number FA01 of R2. Make sense? So we can assign 4.2 to this. Do you guys understand what we are doing here? Okay, so in order to make communication between these networks, this network, we have to assign some IP address to these ports also, right? In order to make them work, you have to assign IP address to them, right? So we have to assign IP from the same network. You have to make sure that the IP you are assigning on this port has to be from the same network which you are assigning on this port. So you cannot go with something 192.168, let's say 10.2. That won't work for you. So the ports from, we can say ports from different routers facing each other has to be in the same network. Is it clear now? They have to be in the same network which are facing each other. So we know that Ethernet 1/0 from router number 1 is facing FA0/1 from router number 2. So we have to make sure that these two ports are in the same network. So let's quickly configure them also and move ahead with the practical. We will go to the port interface Ethernet 1/0. Then we assign IP address to it as 192.168.4.1 with the subnet mask. And we type no shutdown and enter. Then we go to router number 2. We enter exit to get back to the configuration mode, and we'll go to interface FA0/1 and we'll assign an IP address 192.168.4.2. Type no shutdown and the port is up. We are using static routing and we are learning about that. So as of now, we have just configured the IP addresses to the ports and to the PCs using DHCP. Is it clear till now? Now we will move ahead and we will learn how we can configure static routing on these routers to make these 6 PCs communicate with these 3 PCs. Okay, so we'll go to router number 1, and now we are going to use some show commands. Show commands are used to check but all configuration is there on the router already. So we will go to the enable mode where show commands work. So you have to type show IP route, and once you press enter, you will see a table which is called as routing table for the router. So if you scroll down, you can see that there is a network 1.0 which is directly connected to the router, right? We have a network 1.0 here which is directly connected to the router 1, right? Then we have 2.0. Again, this also is directly connected with the router. Then we have 4.0, which is here on the Ethernet 1/0. And if we check the same on router number 2, if we go back to the enable mode and type show IP route, then we can see that there is 3.0, which is this network. Then we have 4.0, which is there on FA0/1, right? Now, I want you guys to understand a router can make communication between devices. Okay, we have some questions. Which routing protocol? We will use static routing, then two routers, and so they communicate. Yes, they can communicate if they are in the same network, and it doesn't matter if they are connected through a router. Suppose you have two sites in both run different. Yes, thank you for the explanation, Dilkush. I hope that resolves your doubt. Okay. So now, I want you guys to please focus here now, and we can discuss your doubts after this. Since we have only 3 routes in the routing table of our router 1, the router 1 can make communication between these routes only. I want you to answer this, that if the router 1 is not aware about 3.0, which is nothing wrong, we can see that he don't have any information related to 3.0, then can he make, can it help making device from his network communicate to devices from 3.0? Like he must have the knowledge about 3.0 before making the communication possible, right? Till the time he is not even aware about that there is some 3.0 network there in the topology, how will he help the devices, right? So we will inform the router 1 about 3.0, and similarly if we look into router 2's routing table, we can see only 3.0 and 4.0 is there. So we will tell router 2 that there are 2 other networks as well, which is 192.168.1.0 and 192.168.2.0. So what we are basically going to do here is we will tell router 1 about this network, which is 3.0, and we will tell router 2 about these 2 networks, which is 1.0 and 2.0. Make sense? Awesome. So let's quickly begin and inform these routers about the networks which they are not aware about. So on router 1, we just have to tell him about 3.0. So we will go to the configuration mode. You can move to configuration mode by typing conf t. So once we are here, we will tell him that there is IP route 192.168.3.0. Then we will type the subnet mask with it. Now you have to tell him that using which interface can he reach 3.0. I want you to answer this in chat. This is not RIP. This is static routing. So I want you to answer this. Out of these three interfaces, which is FA00, FA01, and Ethernet 1/0, which port will help him to reach 3.0? Great. So we have some answers, which is Ethernet 1.1/0, which is absolutely correct. So we will now, after like telling him this is the route, this is the subnet mask, you also have to tell him through which interface he can reach there. So either you can type Ethernet 1/0, or you can just type the IP address of this interface. We know that the IP address of this interface is 192.168.4.1. So you can choose either ways. That's not an issue. And we will use the IP address 192.168.4.1. So this 4.1 represents Ethernet 1/0 only. So once you press enter, oh, I'm sorry guys. You have to just type the IP address of 4.2, or you can simply use the simply let me make this easy for you. We made some mistake. You don't have to like type 4.1. You have to type either the IP address of interface which the port is facing, or you can simply type the interface name. Yes, next hop IP. So once we are done with this, okay. Yes, we have some answers here in the chat. So what we are basically doing here is we are telling the router about a route which is 3.0. We are telling about the subnet mask. Then you have to type the IP address of the next hop, or you can say the router which is facing it. Or instead of that, you can simply write Ethernet 1/0, whichever way you find it easier, you can use that. So we are done with this, and that was all, guys. Now, if you press exit and try seeing the IP route table, the routing table of the router, you can see that there is now another route which is 3.0 in the routing table of router 1, right? We can see 3.0 here now. Now the router 1 is aware about 3.0. But still, if you try to make these PCs communicate with these, it will get failed. You see, it gets failed. Why? Because router 1 is aware about 3.0, but router 2 is still not aware about these PCs or these networks. So we will quickly configure this with static routes, and now let's try using the interface name. So we have to type IP route, and we have to type the network ID at the subnet mask. And you can either type the IP address, or you can just simply put the name of exit interface. So that's something where the packets will move from. So you have, I'm so default route with them. Just a minute, guys. I'm making some mistakes here. Let me see what's the issue is. Yes, Dilkosh, I know that. I'm just going to repeat the same, and just a minute. I'll remove the route from the router to perform the same process again. Okay, great. So we are good now, and now the thing which you are seeing here is the routing table of router 2. Now I want you guys to understand why we are just adding 1.0 or 2.0 into this. Uh, Even if you try pinging from this PC to this PC, it will still get failed. Now the question is why? Because the packet will go from here, will reach its router. Now router will send again this to router number 2. The packet will reach PC6, but when PC6 will try to reply from here, the packet might reach router number 2, but after this, since router 2 don't know about any of these network, the packet will get dropped and the communication will get failed. So we have to tell router 2 also about these networks. So we will go to router 2. When we see the routing table of router 2, we can see only 3.0 and 4.0 in its routing table. Now we will go to configuration mode and we will type IP route 192.168.1.0, then type the subnet mask. After that, you can simply use the interface name of the router. So through which it will take exit. You cannot use FA00, right? You can only use FA0/1 since that interface is going to help him reach 1.0. So once you press enter, it is configured. Then we go to IP route and type 2.0. Then again type the subnet mask and interface name. Now if we take exit from the configuration mode and say the router that show IP routes, you make some mistake, it will show you an error. Now if you see that there is one more route 1.0, 2.0, then we have 3.0, then we have 4.0. So is there any other network, I would say, is there any other network which you can see on the topology and which these routers are not aware about? No, right? So if we go to router 1's routing table, we can see 1.0, we can see 2.0, then we have 3.0, we have 4.0. So now both of these routers are aware about all of the networks which are going there in the topology, and the communication between these devices should work now. So we will go to packet, we will try pinging from PC0 to PC6 and let's see whether it works or not. So if you see, it gets successful. Similarly, if you try pinging from any of these devices to any other device from different network, it will get successful. So first few packets might get dropped, but you don't have to worry about that. You go to command prompt for a better understanding. You can type ping and the IP address of the PC, let's say PC8, which is 192.168.3.5. So if we try to ping it, oh, it's 3.4, I am sorry. Okay. The IP is 3.4 for PC number 8, and when we try pinging 3.4, let's see if that works or not. Okay, the first packet got dropped. Then after that, we can see that 3.4 is replying. So yes, ping got successful and these devices are successfully connected. Do you guys understand how static routing works? Rachel, we can look into this later on. We'll talk about this later. As of now, let me know, were you able to understand this? Great. Yes. Okay. Very Ricky, I will share them, and let me just write them for you. Uh, okay, let me take the snapshot first. Okay, so this is the topology which we have tried using, and now we will look into the configurations of these. Okay, so first of all, I'm writing here the configuration for router number 1, and I want you guys, whoever have missed or might face some difficulty in configuring the network, can look in the configuration which I am typing, and others can try meanwhile. Meanwhile, they can try doing the same at their end. Okay, so there's one more question. You can choose any of these. So when you try to understand them, it says NM1E, which means one Ethernet port, and then we have one FE2W. So these are just a representation of port numbers. So we used 4E, which was 4 Ethernet ports. Similarly, you can use any of these, which helps you. Okay, is it clear? So you can basically use the 4 Ethernet one. This will help you. And the router already have 2 ports. So since 2 of them were used here, so we just added 4 more to make this connection possible. Now I am typing the commands, and whoever thinks should look into this can revise through this, and others can try configuring the network at their end on packet tracer. First of all, you will go enable, then you enter the configuration mode. Once you are there, you will go to interface FA00. Then after that, you have to type the IP address 192.168.1.1, add the subnet mask, then type no shutdown. Okay. Once you are done with this, you can take exit from the interface and go back to the configuration mode. And now we will move to interface FA0/1, and we will assign IP address to this 192.168.2.1. We will add the subnet mask. Then we say no shutdown. Then after this, we have to configure the DHCP pools for both of the network. We write IP DHCP pool A. Then after that, you add the network, which is 192.168.1.0 with the subnet mask. Then you inform the router about the default gateway, and you type the IP address of the same. So there's one more thing which you can look into. Once you enable it, you go to configuration mode. You can type host name and enter the name. Let's say we enter R1. So the name will change from router to R1. So in order to change the name of router, you can use this command. Similarly, if we go to router number 2, we go to configuration mode, we type host name, then after that you have to enter the name which you would like to assign. Let's say R2. So the name changes from a router to R2. So this might help you in order to differentiate between devices. Okay. Okay, so now we created the DHCP pool A for network 1.0. Similarly, we will go to DHCP pool number B and we will type network ID for the same, which is 192.168.2.0, then 255.255.255.0. Then you have to tell it about the gateway IP, which is 192.168.2.1. Once we are done with this, we can take exit from the interface, and now we will tell him about the IP route 192.168.3.0, which it was not aware about. Edit the subnet mask, then we will type ETH1/0, which is the exit interface of the router. So enter, exit, and that was all for router number 1. Now let's understand what works in router number 2. Okay, so now we will see the same for router number 2. We will enable it. We'll go to configuration mode. Then after that, we will go to interface FA 0/0. Okay, let me do one thing. Now we are going to work with router number 2. We have enabled it. We have entered the configuration mode. Now we entered the interface FA00. We will assign IP address to it. IP address 192.168.3.1, default subnet mask. Then you type no shutdown. And once you are done with this, you can take exit from the interface. Then after that, you have to create the DHCP pool. Let's name it as C. We tell him about the network. Tell him about the network which is there, 192.168.3.0. Add the subnet mask, then the default router IP. And we are done with the DHCP configuration. After this, we can move further to add IP routes to its